good morning to you if you're joining here from here. Otherwise, I mean, again, it's morning for me. So very good morning for everyone. I welcome you to the LaTeX workshop day 1. And the idea is start from the very beginning of LaTeX and progress through until we become advanced LaTeX users. Okay, so that's why I asked Mr. Supun, the president of the Mathematical Society, to give us about 8 weeks so we can slowly prepare ourselves to be masters of typesetting. Okay. So welcome again. About myself, I am a senior lecturer at the Faculty of Science, Department of Mathematics, Faculty of Science of the University of Peradeniya. University of Peradeniya, but I can see there are a lot of students who I have not even seen, which means most of you might be joining from outside. I am assuming that no one knows nothing about LaTeX. Okay, so first of all, if you think LaTeX is a kind of rubber and you are here for improving your knowledge about rubber, I'm sorry guys, this is not the place for you. So LaTeX software. So here we are to improve our typesetting skills. So it is very much like something like software that you use, but way better if it comes, if you're doing, yes, it is not rubber. Okay. So other than that, from the very basics and move up. So I have not just supporters, but we are, so next week you're going to see Vindhya, and the week after you're going to see and then you're going to see Shashika and Shashini, all of our users of LaTeX, and including myself, because we are not, I mean, I'm not a, but I have been using LaTeX for about 10 years now. So maybe this particular lesson is not for you, but in the future, you can also learn some functionalities of LaTeX taught us. But basically, we are starting for the very beginner. So starting, so today we are going to do some things with LaTeX. So what is class today? So by the end of this presentation, so by the end of my presentation, you should be able to what kind of things are LaTeX and LaTeX. Okay, and you're going to learn to pronounce LaTeX is the rubber, okay, and LaTeX is the typesetting. Know how to install LaTeX editing software on your computer. Used when I learned LaTeX about 10 years ago, we did not have on this was we had to install one of those LaTeX distributions. It also came with a rudimentary compiler. But you distribution, and then on the top of that you install another software. So usually if you want to steal it, but I think nowadays everyone is working with online. Yesterday I believe Mr. Supun put a link to a software, stepwise guidance to how to go into all of this. So I think that is the problem. And then yesterday night I was thinking, so I just here via your computer. But then I thought, okay, so maybe some of these students, some of these participants might not have computers. So what if they want to join with their phones? You still can do LaTeX with your phones. I don't know how convenient it's going to be, like just if you're watching it through Zoom and then also trying to type it out. But you can do it, and the software is called VerbTech. Okay, so you can either use software in your on your computer, or you can use online software, online LaTeX editing software, or you can use LaTeX on your Android phone. Okay, so I'm going to focus on this online LaTeX editing software because it's very easy to start with and it is convenient, unlike LaTeX in mobile phones. And then once you go in, once you get started, you should be able to identify main components of the document and define terms like classes, packages, and commands. And then you should be able to set up a document. So setting up means you're selecting the paper size, using document margins, page numbers, headers, and footers. And then once you do that, I mean, I don't really want to do hello world LaTeX document because it is not I mean, LaTeX is a programming language as well, but it is not used for programming. So we have to type in a meaningful document. And then you are going to learn things like the equation mode, the text mode. So changing fonts, sizes, changing typefaces, and changing font colors, inserting tables, inserting figures. And then I'm going to give you a functional LaTeX document that you can recreate. And then finally, identify some even more LaTeX add-ons that work with other environments. Because once you become a functional LaTeX user, okay, this can be very soon. This can happen very soon. So probably by end of this presentation, you should be able to at least think of becoming a functional LaTeX user. And then what happens is you're going to look for LaTeX everywhere. Like when you text, you're thinking, okay, can I use LaTeX here? In Facebook Messenger, can you use LaTeX there? And let's say when you write an email, can you use LaTeX there? So all these things, like people ask, like one of the things I get from LaTeX users, like when I do some other presentations, they would ask me, is LaTeX available in this platform? And most of the time, the answer is going to be yes. I mean, even when you do, if you're a web designer, if you're designing a website and you're working primarily with HTML, CSS, and JavaScript, but in that situation, you have to insert equation and all, you can have LaTeX there as well. So there are multiple LaTeX add-ons. I will discuss very simple things today. Okay, so these are the ideas. So I think if we are able to achieve these objectives, I think my presentations will be a success. So 10 objectives. Let's see. And if you have any questions, if you have any questions, concerns, please type it in as a chat in the chat, and I'll listen to you and I'll come back to you. Okay. Right. So what is tech? Okay. So LaTeX. So in order to understand what is LaTeX, we need to understand the bedrock, which is, tech. So usually, about programming, I mean, there's nothing to add with the history. But I thought, okay, this one has a nice history behind it. And it was created by Donald E. Knuth in 1978. Now that's a photo of Donald E. Knuth because I think I do respect this guy. I mean, I do respect this guy. The reason is that the story goes that he wanted to, he's a computer scientist, and he wanted to publish one of his books, and it was a monumental book. It is called The Art of Computer Science. And when he wanted to publish it, he found that the typesetting program, so people were shifting from this old letter set typing to newer typesetting based on computers. But he found that it was very aesthetically unpleasing, or in other words, it was ugly. So what he did was he just set aside the project for his book and created this new typesetting language that is called LaTeX. Okay, so that was amazing. Like, this guy says, okay, this is not enough for me. So he just goes and create a whole new typesetting language. I mean, it's not a typesetting, not just a typesetting language. It is in fact a Turing complete programming language, which means you can pretty much program anything with TeX or even LaTeX. And there are programs that are written in LaTeX, and I think in the 7th week or so, we are going to write some programs on LaTeX. But again, it is not used for that purpose. Nowadays, it is used for mostly typesetting, but it has programming capabilities like loops, functions, and variables and so on. Okay. And then the goal was to allow anybody to produce high quality books with minimal effort. So that was what he was up to. And he later published, I think it was 7-book series of the art of computer science or art of computer programming. And I think it was well received. It was one of the monumental books. Yes. Okay. And then LaTeX can be considered a LaTeX. So that is TeX, and it allows 2 main goals. One is to allow anybody without a lot of practice to produce high quality books with minimal effort. Now, if you ask me, like I haven't learned LaTeX in a workshop like this. Okay, I'll tell you my journey of learning LaTeX. So again, very similar thing happened to me. I mean, I didn't invent a programming language; it was already there, and I had to do it in Word. And this was about in 2009. I was in analysis, and I found that Word was very inconvenient. And then I asked my then supervisor, so is there any way that I can use, is there any different software I can use? And he said there is something called LaTeX, but he knew about that, but he didn't know about the new iterations. So he just asked me to try it. And I was almost finished with my thesis, so I submitted it using my Microsoft Word. But then when it came to publishing my thesis as an abstract for a different congress, I just went in there and we need it or something like that, and the idea was very intuitive, so I could just learn it by myself. Okay, so there was no one taught me. I just guessed worked, and while once within a week or two, I just became a good functional LaTeX user. With that, I don't have any like formal education in LaTeX, but that is enough. Like you guys, 80 to 90% of all LaTeX you're going to learn today. Okay. And then another thing is to provide a system that would give exactly the same results on all computers at any point of time. So that is also, a nice thing to have, because I also use Microsoft Word in my computer, and it's a different version. And then when I transfer it to the other computer but there are certain differences. Whereas if I computer, even an old computer, when I compile it, I get exactly the same results. And that is TeX. And the problem with TeX is there's a huge learning curve, and I have never even opened TeX because we have LaTeX. Now think of LaTeX. The analogy is like assembly and the language C. Okay, so assembly is again a programming language, and C is based on that. And C is much more functional because it's like it contains a lot of things from assembly that is more user friendly. Programmers might disagree with me, but I mean that is very similar to what LaTeX does. So it can be considered as a macro package. So a lot of things in TeX is condensed and can be done using a single command rather than going to the basics. So that is what LaTeX is. And it is an easy to use document creator, and in the core of LaTeX you have TeX. So without even knowing the word of TeX, you can use LaTeX. So how do you get started? Okay. How to get started? Okay, so now this is it. So on your PC or laptop, you can install one of the LaTeX distributions. So there is one, and remember, LaTeX and Tech are both free and open source, like anyone can use it anywhere. But there are softwares that is based on LaTeX that is not free. Okay, so things like I mean, there are scientific word processing software that are based on LaTeX, and even Microsoft Word now have LaTeX capabilities inside. Okay, but still there are a lot of free software that you can use with great effect. So on your PC or laptop, usually you install MIGTech. So I will show you the website for MIGTech, and it is a free tech distribution. So you can use that, and it comes with the editor, which means with MIGTech you can do everything. But I think it is a very rudimentary editor, because the editing part is not the job of MIGTech. The LaTeX compiler is there, so you can install any other software on the top of that. So what I used about 3 years ago for my thesis was Tech Studio. That is very popular. You can Google it and install that. But again, I have not used it for about after that, because I found using Overleaf was way easier than using anything else. Now, if you're again adamant on using your Android phone, there is a software called VerbTech. You can directly download it from Play Store, and you can start it right away. However, if you work on your PC or laptop, just log into Overleaf, and it is a browser-based LaTeX editor, which means it is on your browser. There's nothing to install. I mean, there are, if you use random things, random packages, you have to put it there. But other than that, all the basic packages are included. Nothing to install. You can start right away. Okay, so I'm going to start and go to Overleaf, but let me just give you a very brief overview of what are we going to do in the next 8 weeks. So this week, you're going to get started, and you're going to just learn all the basics of LaTeX. Okay, and the next week, Vindhya will take over, and today I'm going to show you, and you're going to be able to start and edit a very simple document. So it includes mathematical formulas, it will include borders, and it will include margins, and it will include header and footer and those things. But I'm going to do it very informally. So by end of today, you're going to be a LaTeX user. But then next week, Vindhya, Miss Vindhya, she is a graduate of the university, a very recent graduate of the university, and she will show you exactly, most of the time, one of the most frequent uses of LaTeX is writing a paper, research article. So research articles contain abstract, it contains sections, maybe it contains table of contents, figures, and also it contains references. So all these things, she's going to formally teach you how to do that. And then week 3 is, so week 1 and week 2, we are going to focus on a single document, single LaTeX file. Whereas week 3, Mr. Samit, he is also a graduate, but not very recent. He graduated last year, and he will teach about projects with LaTeX. So if you want to write a book, or if you want to write your thesis in LaTeX, you can use report or book classes, and then he will teach you how to do that. Okay, so when you do it, so there are certain steps that you have to make, certain organizational things that you have to make, so that it's easily reproducible, shareable, and also you don't get confused inside your own book. Okay, so he is going to do projects with LaTeX. And in week 4, Shashika will take over, and you can do presentations with LaTeX as well. And they look beautiful. Okay, I did not make my presentation with LaTeX because I was in a hurry. But if you have time and if you're presenting basically mathematics, you can do very pretty presentations from using LaTeX, using the Beamer class. Okay, he's going to teach all about presentations with LaTeX. And in week 5, Shashini, she's already here. She's also also a graduate of University of Peradeniya, a very recent graduate, and she will teach graphs, figures, shapes, even 3D shapes with graphics with a LaTeX package called TIX. Okay, so you're going to learn all about LaTeX graphics. There are 2 parts. This is the first part with graphics, and then I'm going to take over and I'm going to teach you even more graphics. So that is week 5. Week 6, you're going to do a little more advanced LaTeX features like writing your own macros, on environments, on commands, making your own LaTeX style file, making your own LaTeX classes, and then also if you're using your native language in LaTeX, let's say you're doing in Sinhala, Tamil, or whatever language you prefer, you can still do it. So let's say you are compiling a document in Sinhala, but you want to add beautiful mathematical equations in it. Again, LaTeX is the way to go. And you can use different compilers. There are different types of compilers that are suited for different situations. And then also Unicode in LaTeX, we are going to do that. So it's a little bit of advanced LaTeX. And then a little bit of advanced graphics with the TIX package, and then 3D objects. And then we can do, I told you that LaTeX is a programming language as well. So you can in fact program things with LaTeX. Now this is true. There was one program that was, a competition that asked competitors to program the Mars rover, I think certain parts of the Mars rover, and the program that won was written in LaTeX. But we are not going to go to that aspects of LaTeX, but we are going to do a little, let's say, a very primary rudimentary programming with LaTeX. Okay, so if-then statements and some if-then statements are the same as conditionals, and also iterations, loops, and variables, and so on. And then I can share you this exam package where you can write multiple choice questions, but you can randomize the solutions so that you can make different versions with that exam package. And then also I will I can show you some even more advanced functionalities that you can do. So this is going to be some ad hoc things. Okay, some things here and some things there. Okay. So a lot of advanced graphics with some more things thrown in. And in week 8, we are going to sum up everything. We can do forms, we can do hyperlinks, we can do other programs with LaTeX. You can do SageMath, you can do R, we can do Python. So all of these have LaTeX packages, and then there are even more packages. I think here I will just introduce those things so that you can learn them yourself. And if you are a fan of 3 Blue 1 Brown, he has a package, Python package called Manim, and inside he is using text. So I will do some things, I will do some demonstrations of how to do these things, but that's all. So you can see as we go move along, you're going to be little more and more advanced. And if you're in the Google Classroom, if you're in our Google Classroom, I would like you to, I would publish some assignments so you can practice it. It is not going to, I'm not going to grade it or anything, but I think it's also good to have some hands-on experience. So as we go along, so at the end of this lesson, I'm going to put some documents so that you can recreate them, and then we can move on. Now, that's all for the summary. Now, again, I would like you to, I mean, some people say I'm not going to, not even like when I learned LaTeX, I was like, okay, this is the best program ever, and I'm not going to use Microsoft Word ever again, or I'm not going to use any other word editing software. I'm going to use LaTeX. But there are certain things that LaTeX is not for. For example, if you want to, in a rush, if you want to write a letter, probably Microsoft Word is the best program. And if you're making a beautiful magazine that is for popular science, probably InDesign is still the better program. And then if you want to make a poster, a big poster, probably PowerPoint is the way to go. And a presentation that you have to make in a hurry that doesn't contain any mathematics, probably Google Slides or Microsoft PowerPoint is the way to go. So, however, if mathematics or writing mathematics equation or any other formulas is one of the things that you have to highlight, maybe find some software that has LaTeX capabilities inside it so that you can keep using LaTeX. Okay, right. So now I would like to go to Overleaf and I will show you briefly how to get started. And I believe most of you have already done this. Okay. Okay, right. So share screen. And you can see I'm here in Overleaf. So when you go to overleaf.com, this is what you're going to see. Okay. And it says LaTeX evolved, and then you can see a login page here. Okay. Right here. So if you are not registered, you click on register. And they are going to ask you email address and a password. Or better, you can just register using Google. So if you have a Gmail address, you can use that. Okay, so I want everyone to go into Overleaf and go into the main window of Overleaf. So I'm going to do that because I have already registered. Okay. Especially when you are connected from a public network, they will ask these questions just to verify that you are not a robot. Okay, so this is my what I see when I go into Overleaf. So I'll give you about 2 minutes to get in there because we are going to follow along in the project. Okay, so I'm going to give you about 2 minutes. Okay. So one of the nice features about Overleaf is it allows you to share the document with someone else. So you can see this is what I get in my window, and you can see that some of these are owned by me and some of these are owned by other people. So they can share their document with me and then we can collaboratively edit it. Now, the free version of Overleaf, I think they allow only one editor. And what happened with me is when I was, so Overleaf was one software and there was another software that was called Share LaTeX. And I was working with Share LaTeX for a long time because it was very convenient. And then these two projects merged with each other. So while it was Share LaTeX, there was this one feature that if you share LaTeX with I think 10 people, they give you some some premium features, and that that included unlimited shares. So what I did was I did the LaTeX workshop, and I asked everyone to sign in with the link I provided, and I got more than enough users. So I got free features. And when Overleaf and Share LaTeX combined, it translated into my Overleaf account, and I still have this one premium feature that I can share with multiple people. I think with the Overleaf, I think you can share with one or maybe three. I don't know, but not many. Okay, but I also think that there is no feature like that where you can trick other people with your link and get premium right now. So unfortunately, that is not available. So this is your LaTeX screen. This is your Overleaf screen, and I want you to click on New Project. Okay, and you have a lot of different projects here. Okay, academic journal, book, formal letter, homework assignment, poster, presentation, lab report, even CV. Like there are beautiful CVs that you can make with LaTeX, and most of my students, I have encouraged them to make their CVs with LaTeX, especially when they apply to higher studies or other universities. The CV made from LaTeX hits your eye. Okay, Shashini, Linda, I think they have even Shashini, Linda, Shashika. I think they all have their resumes in LaTeX and thesis, and then have other formats. And you can even have posters. But I would like you to open a blank project. Okay, and in LaTeX, it is not in Overleaf. It is not single document, it is always the project. Okay, but we will work on a single document. So let's give a project name, my first. And click on create, and it is going to create your first LaTeX project. So now this is from this point onward, it's going to be a follow along exercise with me. So you're going to see multiple windows. Okay, here you can see the menu of Overleaf. When you click on the menu, you're going to see you can download this document to a computer. Okay, and then you can also download the PDF file that you created from here. There's another way to download your PDF file, but then again download this, and it downloads it as a zip file, and then you can unzip it. You can copy your project, you can count the words of your project, and then there are some synchronization tools, so you can sync with Dropbox, GitHub, okay, and then there are these things. So you can see this compiler, it is PDF LaTeX. So by default, it is going to be PDF LaTeX, but you can see when you click on it, there are other LaTeX versions. LaTeX is there. So PDF LaTeX, it is for the specific purpose of creating PDF files. Okay, and then you have this XE LaTeX and Lua LaTeX. I don't know exactly what XE LaTeX is for, but at the end of this 8 weeks, I'm going to show you what that is. I believe Lua LaTeX is the one that you use for Unicode. One of those two. Okay, so if you want to do it in Sinhala or Tamil or any other language you prefer, I think you have to use Lua LaTeX. I have done it. Okay, and it produces really good documents, but you cannot do it with PDF LaTeX or LaTeX. The one that is compatible with Unicode is Lua LaTeX. And then you have the version. Just use the latest version. And then you can select, because sometimes you are going to have different documents here. Okay, so right here I have only main text, but then you can have multiple documents here because this is not a single document, it's going to be a project. Okay, so right now I'm going to usually the main text, the main document, and then there there's a spell check option. Okay, and PDF viewer, built-in or native. Usually you can use functionalities, but if you want to say native, that would open a native PDF, whatever you have in your computer as your PDF viewer. Okay, and you can have multiple themes here. I'll just not meddle with that overall theme, so that is going to change the look. Again, would not mess around with that. And then I don't know what these things are, but then font sizes you can select, and then this is actually font for the editor. Okay, and finally, I would like you to click on this show hotkeys link, and you're going to see all the hotkeys. Again, we are not going to use all these things. I probably use Control Z, Control Y, and then probably Control C, Control V, all these basic ones. But there are other hotkeys. So if you love to use keyboard to move around, okay, this is the one for you. Okay, and another one that I would like to use is Control Space for references. But again, if you just use Cite, it is going to give you all the references. Okay, you have a file outline. Okay, so that is an easier way to navigate. If you have a large file, it is going to give you an outline. Okay, and once when you change the document, this outline is going to change. And here, this is go back button, and then here you can create new file, and all the LaTeX files end with .tex, and then you can upload from your computer. You can upload from another project that you have, and then you can upload from other sources, and you can actually make folders in here. So if you create a new folder, you can just create a folder name, and it's going to create it. And then you can upload other files like graphic files by this upload button. And then you have rename, so you can rename main.text, and not to do that, and then delete button. So that is the basic outline here. And then on the right hand side, you have review. And if you click on review, you can do, I think track changes is a premium feature. But you can click on something and you can add comments. This is very useful when you are working with someone else. For example, when I work with my students, undergraduate students, they write their thesis in LaTeX. So they are going to by default share it me for the first time, and then I can go in there and I can add comment. Okay, change this and change that. Okay, so that is there. And then you have a share button. With it, you can share it with multiple people. I have never used submit button. I don't know what it is for. And then you can look at the history of this file. I have not changed it, therefore there's nothing in the history. And also there's a chat. I use it not quite frequently, but when I edit, when we edit with multiple users, you're going to see you can actually use this chat so that you can chat with people and get going. So it is easier than adding comments. So this is your file, and you can see there are certain sections. First of all, in the first line, you can see document, class, and article. Okay, and this is the declaration what class your document is. So this can change from book to report to other classes, other custom defined classes. Okay, so let's actually try one. And whenever you hit recompile, you're going to compile it again. And the shortcut for recompiling is Control C. Sorry, Control Enter is compiling, and then either also Control Save. Control S is for compiling. Okay, so with either of these hotkeys you can use, you can compile your document. Right. So the first one is your document class. You can do book. There are multiple classes. When you do book, it is going to get things from the book class, and it is going to look like a book. And I don't know whether Beamer will work like this. Yeah, that's it. That when you say document class Beamer, you can see it becomes a slideshow. Okay. And then there are specific commands that are specific for these document different classes. For example, Beamer, if you want to make a new slide, you should write begin frame. Okay. So let's go back to article. See, if you do a mistake, you can see there's an error. And one of the good practices with LaTeX is, let's say even sometimes you make minor errors. Okay, so you make a minor error, but this document still compiles. For example, so I'm typing. If it's a minor error, and I'm probably if some of you might be using your phone, so I'm going to increase my font size. So now you can see that I typed here. Okay, you're not going to see the error. It says something is a minor error, but you can see there's an error message right here, and it says there's one red error. Okay, I practice one of these things. Okay, it's all right. It's all right. Supun, can you mute him? Yeah. Okay. Cool. Right. So you can see that this red one here, like whenever I do whenever I type any document with LaTeX, I make sure that there are no red errors. Okay. So one good practice is make sure that there are no errors. Make sure you get no red errors. Okay, and even for my students, I ask them, please make sure you get rid of all the red errors before you send the document to me, because it's very annoying when you have red errors. The first thing you want to do is go and see what this error is and get rid of it. So get rid of all red errors. And there are yellow errors. That means there's some formatting that went wrong. It went the way it was not intended. I will check all this yellow errors, but sometimes when you do big documents, there are certain things that you manually fix, and then it will result in this partial them. And what you do is, if you get a red error, okay, you click on it and see what happened. And it gives me the error message, undefined control sequence. because this \f is not a recognized LaTeX document, a LaTeX command. So if it, so what happens is when okay, all right, thank you, Supun. Okay, so whenever you use this \, LaTeX recognize, okay, now I have to go to a command, and he is looking for what is \f. Okay, so let's say okay, and if it will search in its other packages whether it is there, and if it is not there, he is giving me it's a there is no command \. Okay, so it gives you undefined control sequence, and it tells you the line 17. So it says line 17 \f. Okay, so now you can go to line 17, and it also gives this red cross here, and you can see that this is the problem. So you can okay. Now when you compile it again, you're going to see the error is gone. Okay. Right. So make sure whenever you type have this as a habit, no errors. Okay. Now I explained about document class. So that is the class you're using, the type of document you're using. And then you have these use package commands. Okay. Now these are so, and then you can see this begin document command right here in line number 11. So when that is where you begin your document, and before that, everything here is called the document preamble. So all these things right up to here is called the preamble. Okay. This is where you write everything that is required for your document. Now, if it's a small document, you can do the preamble right there. Okay, but when you do a thesis or something, usually you are going to include a huge number of packages and huge number of custom commands. In that case, you are going to have it on a site as preamble.tech. Okay, but today we are just going to have the preamble right here. And you can see multiple different commands in the preamble. And first thing you can see is use package input enc. Okay, so there are multiple packages. By default, overleaf include this UTF input enc. I don't know exactly what that is. I just keep it there. So as you can know, as you can understand, I'm not a huge expert in these things. So I don't know the inside functionalities of this, but that doesn't matter. Okay, right. But let's see if what happens if there are certain packages, but you without specifying the package. So I'm using this command. I believe this is in. I used the command, and you can see there's an error message. It says undefined control sequence. So the first error message that I had. The reason is this is how you write a fraction in LaTeX, but you can't. The LaTeX your LaTeX version doesn't understand that it is a command. The reason is there are other packages that tells LaTeX, like there are macro packages that tells LaTeX if the person write dfrac, use this. Okay, for example, if I write frac, then you can see that there's no error and I can get a fraction. But you can see again that fraction it doesn't look good. It is on the line. So I want it a little bigger, and that's where I want dfrac. But dfrac is not included in the common LaTeX commands. So there are some commands that are very common. So it comes with LaTeX. But most of these you have to use packages. Now I'm going to comment this out. So you can see what I did. I used the percentage sign, and that just comments things out, means LaTeX doesn't recognize this line. Let's compile. Okay. So UTF doesn't do anything to that, but you can see this is not, now this package is not used, but even if you don't use any package, it still understand what frac is, right? Okay. Now let's actually use the package. So I think AMS math. Okay, AMS math package. Once you use AMS math package, that includes a lot of different math commands. So if you write dfrac, I believe this is the package that gives you the dfrac. Okay. So when I do it, I automatically put some certain packages. I'm going to tell you. One is AMS math. One is AMS sim. Okay, these two I always use because I think most of these commands are in either one of them. Sim is a symbol package and math is a mathematics rendering package. So I always use them, and I use graphics. The second one, graphics. I don't know what the first one is, but graphics with the X, and then X color. This is a good package for colors, especially if you want colored font. You would like to use X color. And then what else? If I want to do graphics, I would use Tix, but right now I don't want to use graphics. I just want to use very basic, but there are other packages. So there are custom made packages by people that are there, but most of the packages, like 99% of what people use is included in overlay. Now, if you want to make your own package and put in there, you can do it. And the package files, instead of ending with the TEX, it ends with STY, style. Okay. And then document class files, you can also do your own class, on document class, and that would end with CLS. So it's like, you know, if you have worked with HTML, these things are like CSS. Okay. How to define these styles, like document class files. Okay. Now moving on. If I need any other package, I would use the packages. Okay. And then you can see these are the packages, and then you can also do custom commands. And it's also good to have some comments so that when you share these things, other people can read. So readability is one of the things that would be nice in all documents. So I would say the packages I'm using. And then also another one I use is geometry. Geometry is the package for usually margins, borders, and also paper size. And it's good to also denote for what this. So color. And then symbols. I don't know which one is this. I just have it there. Okay, so now you can see right here. So anyone else reading the document can also see what I'm doing. Okay, right. And here, this part is the custom title part. So and okay, so that is your first project. Author is there, and then you can also have subtitle like commands, and then date if you don't write the date. will remove the date. And then you start the document, and then inside here, whatever you type is going to be seen most of the time. Okay, you can do other things, like if you comment things out, not going to see it. And then you can see these sections. Okay, and then you can see this command make title. Let's see what happens if you don't use that command. If you don't use that command, the title is not going to appear. See? Right? And the make title command tells the title to appear. And then section will, if your document is a multi-section document, you have section 1, section 2, it will introduce sections. Okay, so let's say another section. And on the left hand side, you can see now your file outline is now, it contains introduction and preliminaries. And when you compile it, you're going to see introduction and preliminaries. And you can add subsections to sections. So again, file outline, you're going to see the subsection now. And when you click on it, it will take you to that line where it starts. And it will automatically number subsections. Now, when we move along, I'm going to see, like, if you want to now name this as A or B or anything else, you can do that, but you have to modify certain things. Okay. And then you can also have, if you want subsection, yes, it is subsection. Okay. Right. So up to this point, I would like you to ask me any questions that you guys have, because it's 11 a.m. and I want to see whether you guys have questions, whether you got stuck in there. So how are you guys doing here? I'll just wait. Do you guys have any questions? Yeah, I have a question. If you want to start in a new line, do we have to use? Yes, there are certain commands. Let's see. Okay. So let's see. Good thinking. Let's see what n does. Usually, my preferred go-to command is double backslash. When you use a double backslash, you're going to get a new line. In fact, you're going to get a new paragraph. Can we add pictures in this document? Yes, you can add pictures. I will definitely come to adding pictures. Okay. So subsection is so now you can see that this line goes to a new line, and then you can just keep on adding double backslashes so that it will skip lines. So double backslash in fact start a new paragraph. Okay, and let's see whether what n does. There is no n command. So I don't really want to make Vidura unhappy. So let me just do it like right here. So Vidura, what you can do is, if you want to say, okay, so you don't like n, let's see, how about new line? New line will take you to the next line. So, but if you really insist of using n, what you can do is you can make your own command. So what you do is new command. So go to the document preamble. Okay, so that is before the document, you can define your custom command. So let's say you have to always use this new line command and you don't like it. So what you do is here you add custom commands. And let's say new command and then n and then and then you're going to see when you put n here, okay, and then again look at what happens. So there's this one right here. Okay, now LaTeX recognize. So what it does is it looks at this and he will look here and he can see that it is a new line command. So it will just go to new line command. Okay, and you can see that what I did there. Okay, so let's again new command. So there are three things in new command. The first curly bracket, a second square bracket, and third curly bracket. Okay, I'll just briefly, because this is a little bit advanced. I was not thinking of this, but let's do this. Okay. E fraction. Okay. In the second bracket, so if you don't want it to be a command that accepts arguments, you can say, you can just remove this and it will still work. But if you want this command to accept arguments, okay, so let's say big fraction takes two numbers and it will put this first number on the top. It will put the second number on the top and put the first number in the bottom. Okay, so this is different. I would say reverse fraction. Some refract. So what refract does is it will take two commands, okay, and it will make it a fraction and put the first one on the bottom and the second one on top. Okay, so I would say this is a fraction, and I'm going to say fraction dfrac, and it is going to say 3x plus 1 over 2x minus 1, and this is the reverse fraction, and I'm going to say rev, and it recognizes my refract command right here, and then same thing, 3x minus 1 plus 1 over 2x minus 1. And then when you compile it, you're going to see the normal fraction is 3x plus 1 over 2x minus 1, and the reverse fraction is 2x minus 1 over 3x plus 1. Okay, so you can define whatever custom commands you like in here. I was not planning to use it, but yeah, whatever. And you can see that there is an indent. Okay, so let's take some random text and Now you can see automatically LaTeX will add indents. Okay, and automatically it will justify. So you can see this little indent when you start this, there's a small space and that is called indent. And if you don't like this indent, so that is default, because usually when you write something there is an indent, but if you don't want that indent, you write no indent. Okay, and you can see that indent is gone. Now, very small things here. First of all, I would like to tell you why the dollar signs and then what are the double dollar signs. So first of all, the normal mode. So this is normal. So whenever you don't specify anything, whenever you don't specify anything, it will just write it there. And you can see okay, so you can see this is normal text. But when you use a single dollar sign to for a formula, you can use math mode. So the inline mathematics math mode start with a single dollar sign and ends with a single. And so x equals 3y plus. And you can see the font of the equation is different. So you can see now x becomes in this part is in equation mode. And one more good practice. Okay, one more good practice. Always keep mathematics in okay. So even if a single symbol, okay, so like let x be a variable or something like that, make sure that is enclosed in dollar signs, so that is equation. Okay, so I don't I mean, it is annoying when it doesn't happen, because sometimes people do like something like this. Let x be a variable and y be another variable, and assume x plus y. And some people I have seen that they use dollar sign for every single character, and that is not required. Okay, so this is not required. Okay, some people do that, and that is not required. Single dollar sign to start it and a single dollar sign to end it. Okay, this even works, but why bother? Okay, so single dollar sign to start the equation and a single dollar sign to end the equation is all you need. Okay, and what I see here is, let's actually have some lines in between so that you can see. So here let x be a variable. Okay, so let x be a variable and y be another variable. So these two should be in equation mode. So this x shouldn't be like that. So the correct way would be let $x will be a variable and $y be another variable. Okay, so that is the correct format of this. So now you know the equation mode and the normal text mode. And if you want to highlight an equation, use either $, and you right now you are learning a lot of things. You're learning subscript using underscore, superscript using hat, and then integration, the command is int. And you can see the equation is now in the middle of the page, so it is more highlighted. Okay, but this is not very, we don't recommend, I would not recommend, I mean, I would recommend it if you are going in a hurry, but better to write begin equation, and you don't need $signs, just write down the same thing. And the nice thing is, you get the equation number. Okay, so you get this number so that you can say in somewhere by equation one. So another thing that you can do for begin equation is you can label it. Okay, so the reason why this is important is because sometimes when you are making these documents, you might be adding things in the middle, adding things in the end. So when you write, okay, when you write an equation and you think that is the most important equation, so you start with equation 1, but then later you are saying something like this is by equation 1, and you type it there, and then someone else adds another equation, but because you typed it there, it is not going to change. But if you label an equation and later you can say by equation, and then you can say ref equation 1. So this is called inserting a cross reference, and then this is true. And now what LaTeX does is he will look at, no, she, I don't know, I mean, I'm referring to it as a human. So it will look at what is equal 1 and will look in the whole document, and right here he will pick the number of equations, and when you compile it, it's going to say by equation 1. But if you changed it, so you add another equation, begin equation, and then say sum as n goes from 0 to . And now this equation becomes equation 2, and this by equation ref equation 1, that becomes again 2. So you can, these things are automatically kept in track. Okay, so that I think that's one cool feature of this. Okay, right. So I think we are almost out of time. I can keep on going, but let me see how many things we accomplished today. We just go to the. So now you know the functionalities of Tech and LaTeX. Install LaTeX editing software in computer, work with online tech, identify main components or document class, the document preamble, begin and end document, setting up a document, your first LaTeX document is compiled, text mode, equation mode, insert tables, figures, let's do it really quickly. So you have created the functional LaTeX document, and I'm going to tell you 3 things. Okay. Like when I use LaTeX, there are a couple of other things that I always use. Okay, one is of course Google. So if you have any problem with Google, okay, any problem with like margins, what you do is let's look at, let's Google it. Okay, if you want to margins in, and the biggest source that I love is the community of Overleaf. So when most of these things, the first thing that you get, that you can you use another numbering style for equations such as 1.1? Yes, you can do it. It depends on the LaTeX class, and you can custom name it. And I will show you when you, I think as you go along, you can learn how to do that. Yes, you can do like 1.1, 1.2, something like that. And page sizes and margins, you just go there, and it will have a very comprehensive article on how to use page sizes and margins. So this is one of the things I always use, the LaTeX community, but I always go by Googling, because when you Google it, you are going to get a more specific answer. So that's one. So if you, from this, you can do page sizes and margins. The geometry package is the package that you usually use. You can right here, you can say, if you want a equal margin, you can say margin equals 1 centimeter, and it will give you a margin with 1 centimeter. So now that will add a 1 centimeter margin around. And if you want to play around with margin, you can go in right here, and you can just copy and paste. Okay. So you can just change the page margin, set custom margins to custom pages. Headers, there was one package I missed here, fancy header. Fancy HDR is the package that you use for headers and footers. Okay, so now with that, you can change the header and footer. And again, what I do is Google it, and you get a comprehensive document on how to do headers and footers. And finally, what if you don't find a symbol? So for example, if you want the symbol, like I think if you're a second year or more at the University of Peradeniya, you know that there are things called normal subgroups, okay? And there are symbols for normal subgroups. So this website is very useful. It is not affiliated with Overleaf. It's called LaTexify. And I'm going to put it in the chat box. And what you do is just draw it. So you go in there and draw the symbol, and it is going to identify what kind of symbol is it. And it tells you what kind of command you should use. So here you can say use package AMSSim. So if this command only works with AMSSim, but the command is triangle left equal. So when you use that in the equation mode, let H, and you're going to get that command. So any symbol that is missing, you just go in there, and it will identify it with a considerable accuracy. Okay. So if you want arrows, you can get arrows. So long right arrow. So all these things you can get it from there. So with Overleaf, Google, and Detectify, you can just do pretty much everything in LaTeX. Okay, so I think when I do it, I only use these three things and nothing else most of the time, unless I want to go like, make my graphic on my own. So just one last thing, I'm going to introduce you how to do a figure, how to insert a graphic. So let me just upload documents. So upload from my computer. So you can upload, select from your computer. I'm going to use Math Society logo, and it is going to get added here. And then because you have to use the use package graphics package, and if you want to just include it here, you can just say include graphics and then just write Math Society logo, and it's going to include Math Society logo. Okay. And then if you want to make it in the center, you can make it in the center. So now you can just Google how to put a picture on the center, or how to use pictures, include graphics command in LaTeX or something like that. So you can right here, you can add some other commands like say scale equals 0.5 or 0.25. So scale it. But this is not the preferred way to adding figures. We use begin figure. And when you use begin figure, it will give a figure with the caption. So include graphics again, Math Society logo, caption. This is the logo of the society, and then you label it fig. Is this, you can recall that, and then done. So with that, you're going to get the Math Society label right here, and it says figure 1. This is the logo of the Mathematical Society. So if you don't want it here, there are commands that you can do like H, and you can move it to the previous page if it is small enough. Okay, so now you can see when you say H, it will include the graphic figure right there. If not, the default is it should go to the top of the page. That is the usual way of including figures. Okay, so I think with that, I'm gonna stop the first part of the workshop. So now you should be able to figure things out in LaTeX. So I'm going to put some documents in PDF format, which you have to recreate using LaTeX. Okay, and there are multiple ways of doing that. Okay, I think that would be enough for today. And if you have questions, it is a good time for a Q&A, so you can ask questions.